Hello everyone, Professor Dustin here, and in this video I'm going to show you the sort of quickest, easiest way to get to a color image if you have three separate images. Maybe if you have many different images, but you have them in three filters, in some red filter, some green filter, some blue filter. I am not an expert at this. My expertise is more in measuring the brightness of objects, like you doing photometry. But there's a certain amount of art to getting nice, pretty pictures if you're using high quality scientific equipment, like we often are using our the Mendel Observatory or eye telescope. And so this video is going to try to get us from those scientific quality images to a pretty picture. There's lots of more ways you can get really nice, pretty pictures, and lots of techniques that I don't know anything about, doing various kinds of image processing, like in Photoshop and other tools. I'm going to stick primarily with AstroImageJ. The very last thing I'm going to show you is going to use an open source image processing software called GIMP to do a little bit of image processing on them. But basically, this is supposed to be the quickest way to get from a bunch of images in three different filters down to a pretty color image, the kind that you could like show to your friends and be like, oh, cool, I took this picture. So let's get started. The starting point for us is going to be a whole bunch of already calibrated images. So I'm assuming that you're going to either use eye telescope, which gives us calibrated images, or you're going to use the Mendel Observatory and calibrate them either on the fly or after you take the observations the day after. But I'm going to start with calibrated images, but images that do not have the world coordinate system in them. So the first thing we're going to have to do is give them the world coordinate system. Okay, so remember how we have to do this to load a stack in. We have to load a single image first and then specify what stack to load. So I'm going to do that with one of my M63s first. It doesn't even matter which thing I pick. You can see it's a sort of a fuzzy galaxy. It's actually a nice galaxy, but it wasn't a great night when I took the images. So anyway, this is what we're going to be looking at. If I want to open the stack, I do open image sequence, and then I have to specify which images I want to open. If I'm putting a WCS on them, I can basically do whatever I want because I just want to put a WCS on every single image. But I like to do them by source, so I know what to look for. I can sometimes specify where the images are actually located. That can help. So I just want to pick out the M63, so I just do M63. And you can see that the number of images started at 250, and now it goes down to 30. So there's 30 in there, which is good because I took three sets of 10 for each filter. So then I go, okay, make sure the use virtual stack is checked. And this might take a minute to open them all. And you can like go back and forth using the left and right arrows to see all of them. You can see the names of the files at the top. That tells you what filters they are. This is the B filter. And then here's the R filter and so on and so forth. So I want to put a WCS on every single one of these. This is going to take a while. So I'm going to start it and then walk away, hopefully fast forward the video and stuff. So you do that with the WCS, plate solve using astrometry.net. Here is my user key, which you can use if you like. I'm going to click autosave, skip images with WCS. That doesn't matter yet. That's what I'm going to do for a second processing run. But for the moment, going to leave it checked because it doesn't really matter. Process and stack, yeah. All the rest of these, I'm going to leave checked because I think that's the last thing I did that worked. Now, constrained sky location, this is source specific. So I'm going to uncheck that, leave everything else checked. Yeah, I think that all looks fine. And let's just click start, make sure the show results log is enabled so we can see what happens. And I'm going to click start. And then hopefully we can see at least one of them working. And then I can fast forward the video so that they just go through all 30 because it's going to take maybe like, half an hour or something or longer to do all these. Okay, well, the first one was solved, so that's good. So that at least suggests that the other ones will maybe take a while, but at least be solved. So cool. I'll run this through this and come back with you when it's ready to take another look at. Okay, we're back. That didn't take too long, a little more than 20 minutes, and we've solved a whole bunch of them. Did every single one get solved? No, a few of them didn't. Unsuccessful to try slice 9 might be the only one that didn't get solved. So we want to look at slice 9, I think, and just check it, see what it looks like. I don't see any particular reason why it didn't get solved. So I'm going to try to just run the thing again. Sometimes I change the parameters to try to adapt to what I'm looking at. I don't see any reason why that one didn't get solved. So I was going to run it straight again, and I'll catch you again when the whole thing goes through. But I do want to show you that I'm now going to run skip images with WCS because then it will just skip over them if they don't have it. And it will only focus on the ones that do it. So in principle, I'll only be doing one image this time. See, I'm looking carefully at slice 9 to see See if I can see anything that's obvious. Not really. It is selecting all these stars pretty easily, even these super faint ones. So it's not obvious to me why slice 9 is not working. Okay, so now going back, you can see that actually was solved. So now we have everything that's solved. 9 was solved too. Whatever the problem was, fixed itself. So cool. So now what we need to do is reopen them. I don't know. We might not even need to reopen them. Yeah, actually, they seem to be there already. Yeah, so you can see that the WCS is now on them because as I scroll around the image, the RA and DEC are shown as I go around. So as I go around, that means that there is actually a coordinate system on there in contrast to what it was before. Cool. I guess I'll just reopen them just for safety, just to demonstrate they were indeed saved. Sorry, not that one. Do it from the other image. You had to open the single image, open image sequence. Again, PEM63 is the source I'm interested in, 30. Cool. And now you can see that indeed the WCS has been put in because we have RA and DEC coordinates. Excellent. So now we want to align everything. So that's going to be pretty simple. Just do process, align stack using WCS or apertures. Make sure the first slice, last slice is right. These 3 bars don't matter because we're not going to be using an aperture. We just want to make sure that only use WCS headers for alignment. We're just going to use the coordinate system. They're just going to try to make the images line up according to the coordinate system. I usually like to do align only to whole pixels, no interpolation. Maybe it's better if you interpolate, but from a scientific perspective, I don't like that. So I guess you can argue, but in any case, I'm going to leave the whole pixels aligned to only whole pixels and show the help panel just for the sake of argument. We probably won't need any help. We're probably just going to click OK and it's going to work perfectly. So we're going to try that. Notice that I am aligning all the filters. So I have all 3 filters loaded up. That's not how you want to stack them, but you're going to eventually want to line up all 3 filters to turn into one image anyway. So my view is just stack that, align them right now is a perfectly acceptable choice to make. So click OK. And they're going to pop through them. Going to take a few minutes, but now they're going to align. Cool, done. Virtual stack alignment complete. Aligned images are now saved in the subdirectory. Aligned. Very good. So click OK, close this. And now just to demonstrate where they are, I'm going to go over to my file directory sources, go into aligned. And you can see I have aligned M105, which I've already done. And now I have aligned M63. Cool. So now I want to get just each filter individually, the 10 images that I have in each filter, and stack just those together. So this is going to be a little bit sneaky just because I now have a whole bunch of different labeled files in here. And when I open them as a stack, I want to make sure that I just grab the ones related to this process that I want to do. So I'm going to click open image sequence in new window. I want to now navigate to my aligned directory, my sources. That's the date in my align, select. I want them to be M63, aligned M63. And you see there's 30 now, but I want to open just the 10 in a particular filter. Go over my directory, you can see they're named _V_R_B. So I can just do that. Let's do _R, just demonstrate 10. Cool. Click OK. They should open as 10. Indeed, there's 10 there. I could, go through them real quick to make sure they actually are aligned. They look aligned to me. And then do process align. We've done that. Combine stacks into a single image. Now, again, we have some choices here. A median combine or a sum combine. Now, a sum combine is usually the standard that we want for scientific images. That just adds up all the counts. It increases our signal to noise because we increase the signal to noise, increase the signal faster than the noise. So that is basically exactly what we want. But from the perspective of doing imaging, pretty pictures rather, sometimes it's better to do median because the sum slices, if there's like cosmic ray hits or any bad darks going on, actually a median will allow you to sort of get rid of those because a median will like throw out the extremes and just keep the middle best image, best number for each pixel. So if one pixel has way too many hits in it because it was actually hit by a cosmic ray or it's not appropriately darked, the median will actually pick up the better one. So we're going to do projection type median for these because in my experience so far, our camera, the dark hasn't quite worked out yet. So I think that this is going to produce a better image. So let's do OK for the median. It will create a new image after summing them all together. Bam, and then actually that looks kind of good, right? Look, you can even see some of the spiral structure. So I think the median image combined was the right choice. If I didn't do that, I have a bunch of little dots everywhere. So I think the sum would have gotten me a bunch of little dots. Cool. So I want to save this now. I want to save it as a file that I'm going to be able to search easily. So I'm going to be a little careful about that. So I'm going to save it. You can see I already have in the aligned directory a bunch of like med colors. Those were all my other source. So what I'm going to do is I'm going to call this M63 underscore med aligned fit. So, source, median combined, and aligned, meaning that they have been aligned with each other. And actually, I should put the filter name too. Yikes. Which filter was this? That was filter V. I hope. Let's just check that. No, filter R. Oof. Yeah, make sure you get that right. R. I could get rid of the aligned, right? It doesn't really matter. Whatever. Aligned. Okay, now I'm going to do this to the other two filters. I won't show you that. I'll just do it offline. And I'll come back when I've got that finished. Okay, so now I've got 3 images. I've stacked 30 images down to 3. There's a R, a B, and a V. Now I want to turn that into a composite color image. So I'm going to do this in 2 different ways, this last step. One with just AstroImageJ with a little bit of image processing. And then I'm going to do AstroImageJ with no image processing and then do some image processing in GIMP, which is an image processing program, an open source image processing program. The first way, I don't like it as much actually, but it's a little quicker to the pretty picture. So that's why I'm going to start with that one. And then I'm going to go on to doing the GIMP version as well. And I'm going to do one thing for safety, which is I'm going to copy those images I just made into some dummy images that I can screw around with, because there might be a step here that actually changes the images. So I do recommend that. I did that on my last source and it actually changed the images as I was going. I don't want to do that for saving the images to do another different processing type of program. So I'm going to make some copies and then use those copies to do this process. Okay, so now we want to get things open as a color image. We want to, again, open those 3 filters now as a stack. I had to be a little tricky with how to name them. I'm sure you can figure this out yourself, but the 3 filters have to be 3 file names that are different from all the other file names, but just have different filters. So I had to make sure that whatever I named them, I had a bunch of other things called M63 med underscore. So when I filtered them, they picked up these 3 plus a bunch of other things. So I renamed them to be M63 med R and then copy. Now I have 3, just the filters that this part is unique to only those 3 files. So anyway, so that's what I'm going to do. Open images in a new window. Now M63 mid and then copy. Now I should get down to just 3. Okay. So a little trick here, make sure that you uncheck the use virtual stack. This process I'm going through, the processing of the images, only works when you have a non-virtual stack. So do that, click OK. And they look pretty good. Okay, excellent. You can see they aren't colored yet, but you can see that they have the individual file names and you can flip through them to see what they look like still in black and white. Okay, so the first thing we're going to do is a little bit of processing. So the problem here is that if you look at the histogram, it shows that most of the counts are down here at the very bottom. Computer displays display values of each pixel from 0 to like 255. I think it's an 8-bit display, which is probably 2 to the 8th is 255 or something like that. 256 with 0, yeah. So the problem is that the computer needs to be told how to display each pixel and where. So that's what this contrast thing is doing right here, is saying the 0th should be the left edge of the blue, the top one should be the right edge of the blue. But you can see most of the image is actually in this low range right here. So we're not using very much of the image when we actually look at it. And if we can increase the dynamic range, it means we can see the fainter stuff better and the bright stuff can come down, because if it's bright, we know it's bright. So this process is called stretching, and there's various ways of doing it. A common way is a linear stretch if your image is like sort of well distributed in the light of both bright and dim. But our images are not well distributed in the light. They are mostly very dim. Most astronomical images are like that. So it's often advertised that we should do what's called a log stretch instead of a linear stretch on astronomical images. And that will take enhance the dim parts and not enhance the bright parts quite as much, because our eyes know the bright parts are stars. They're bright. What we want to see is the dimmer parts of the astronomical image. So it's very easy to do that in AstroImageJ. You go up to process and then you do math and then you do log. And that's basically setting up for a log a log stretch. So it asks you to process, and it says there's no undo because it actually will save these images. That's why I was careful about the naming and making a copy, because it will destroy essentially the image you had. Now you might be able to unlog it. There's like arguments about whether that's a legitimate process to recreate linear stretched images, but in any case, we are going to just log stretch it with the saved new image, and we'll do it. Oh, sorry, I was almost very careless. So I shouldn't do this on these straight up images. It's a little hard to see, but on the edges, you can see the edges are black. So that's basically 0 counts. In fact, here are some actual 0 counts. That's below the background. The background on these images is 2400-ish, right? If I zoom around and just like read off the counts. This part I want to just completely destroy because it has nothing to do with the rest of the image. And if we stretch it with that black part there, that part will get included in the mathematics of the stretch. I almost forgot to do that. So let's look at the entire image. I have to crop it. And to crop it is easy in AstroImageJ. Click the square, grab, it's hard to tell how much you should grab, but some approximate size, excluding the outside parts. Oh, the reason it's black is because of the stacking, because the stacking doesn't happen quite on top of each other. So the edges sometimes get some zeros. So that's why we're getting rid of them. Okay, so just highlight that box, do image crop. Crops them all, which is very nice. And now we have some good, nice images. What's interesting is that now the scale is not at 0. Actually, it got pushed down a little bit because that lower part were the part that had actually 0 counts in them, even below the background. So that wasn't even the observed sky, right? Okay, so now we're looking at all the images. I've cropped them so that they all have, basically there are no zeros on any of them anymore, we hope. And so now I'm going to go up. Now I'm going to do my image stretch, which is process math log. Going to do them on all 3, do yes. And you can see that hump that was right down at the bottom got stretched out some, and it mostly enhanced the dim part and didn't enhance the bright part quite as much. So these are sort of more, and you can see the actual image of the galaxy got bigger, the dimmer parts got brighter. That's essentially what we want. Cool. So we are now processed and we're ready to create a color image. That's pretty easy by going to color, make composite color image. Display mode, composite is fine for the moment. And so now we've got some color images. So you can see what we're seeing on this side is pretty confusing. It's red. Up here it says it's the blue image. That's because AstroImageJ doesn't know which image is the right color. It's not picking the color from the filter, which seems kind of dumb, but it's relatively easy to fix this. So what you do is you go to composite, change that to color, and then select, I can see you can select each one individually, but of course they are labeled wrong. Channel 1 is set as red, but is blue apparently, supposed to be blue. So what you can do that is you want it to be set to the file name you use because that's where the original filter was. So just go to make sure it's set, check what color it is, and go to more and just pick blue to be the right filter. So now the first one is set to be blue. Do that for the other 2. Channel 2 says red, but it is green, so change it to red. Channel 3 says green, but is blue, change that to be green. And you can double check that we have a blue, a red, and a green. And now we should be able to go to color, click composite. Cool. We now have a nice color image of our galaxy, and things are starting to look a little bit better. Let me try to make this bigger so you can get a better look at it. Yeah. Details are still not really obvious. Well, you can see some details in the spiral arms and stuff, but anyway, so things are starting to look good. This is basically the end of creating a pretty color picture in AstroImageJ. Now, you can see there are some sort of like grid-like features here. Those are artifacts and will disappear when you save this as a PNG, which I'm going to do shortly. So just be aware of that. But for the moment, I'm just going to save this as a FITS file so that I have it somewhere. Oh, what should I call this? Let's go into the aligned folder. It's source M63. It's got a median combined. It's been log stretched. And I usually also tag it AstroImageJ to indicate that I did the processing in AstroImageJ instead of in GIMP, which I'm going to do shortly. Cool, that looks good. So now I'm going to save that. And finally, I'm going to open this, save this as a PNG as well, because that is sort of the thing you want to share with your friends because it's the most convenient file type. And so just pick the same name, just call it PNG. Sorry, I got my Zoom window, but it's kind of driving me slightly crazy here. Same name, PNG. Cool. And now what I'm going to do is just quickly open it up in GIMP so you can open the PNG I just saved so you can see that this sort of like weird grid-like features have actually gone away. Yeah, cool. That looks pretty good, right? No weird features of any kind. Can zoom in quite a bit, see the nice galaxy structure. Very nice. Looks pretty good. In fact, you can kind of see some of the arm structure and the dots that are the star formation regions in this galaxy M63. Cool. Okay, so that has basically shown the first simple way to get a nice, pretty picture. Now I'm going to go into GIMP and do it the other way. I need to start in AstroImageJ and then move to GIMP, but I'm going to end up in GIMP as well, so I'll leave this open. Okay, so now I'm going to show you how to do all the image combining stuff in AstroImageJ and do the processing in GIMP, which I think produces slightly better images, but I'll show them side by side so we can see and compare them. So I'm going to do the same thing, except I'm not going to do the log stretching. So I'm just going to directly open the image sequence. I need to remember what they're called. Okay, so not the copied, but the 6 medium. This is the ones that I want to open here. The process I'm going through, another thing that I like about it, it doesn't change the actual images. It allows you to combine them without changing the originals. So I do like that a little bit better. Okay, 3 files, click OK. Again, we are going to eventually have to do some calculations here as far as cropping to make sure that the edges don't get included. But actually, I don't have to worry about that yet, or I shouldn't have to worry about that yet. I can just take what I've opened in AstroImageJ straight up and immediately go over and do the make composite color image thing. So I'm not doing any processing in AstroImageJ. I'm just going to display mode composite. And then I'm going to repeat the process I did before. So I'll probably just skip this, but I'm assigning the right colors to the right filters. Okay, so I've got my color images now told to be the right filters. I'm displaying them as a composite image I can see there. So the last thing I want to do is convert this RGB stack to a color image. So now it is actually a color image. It is no longer a FITS file. You can see even up here, it shows that it's a PNG. So this image cannot be saved in the FITS format. We've basically gotten rid of the FITS format to do this image. So I'm just going to go up here and save it as a PNG. 68 med color. Cool. I've already got one there. I'm going to overwrite it based on some earlier work that I was doing. Place that guy. Okay. So now I'm going to open this in GIMP to do the final image processing. Okay, so you can see there are some colors here, like you can see at this edge is like a bright red star. In the center, it does not look very colorful, certainly in comparison to the other one we did, which we log stretched it in GIMP. Now, if you look at the histogram, you can see the histograms of the two look very different. This is the one for the one we did in AstroImageJ. Here's the one we're playing with now. It is very different. So that's the first thing I want to deal with is stretching the image. So before I did a log stretch, I prefer to sort of do it by hand. If you go to colors and then you do curves. Oh, I'm sorry. No, I want contrast. Brightness contrast. Okay. So what I like about about GIMP is that you can play with these and you can see what happens very obviously in the histogram over there. So contrast tells you how wide the histogram is. Now I'm not using the full dynamic range. So obviously I want the dynamic range to be wider. So I'm going to make it actually physically wider. Maybe that's too much, maybe. Because I'm now cropping off part of the image at the end there, right? And this should be updating the image down here, although sometimes it's kind of hard to see that. The brightness is going to slide this back and forth. You can see that currently I am sort of at the lower end. So I want to slide the brightness up so it's about in the middle. Yeah, right about there. And you can see there's a little bit of color coming back into the image. Let me turn up the contrast. And you can see now I'm picking out some more of the image. Actually, this one's sort of interesting. Maybe I think this actually looks a little bit better down there. Yeah, maybe there's the right place. I'm sort of doing a combination of making the histogram look like I'm catching as much of the image as possible and also using my eyes to sort of decide what I like about the image. Well, in any case, this is a very personal decision. I'm going to leave it there and click OK. So this is maybe what I think the best image that I can get out of this process using AstroImageJ without processing and processing only in GIMP. But you can actually flip between the two images in GIMP. And actually, in this case, I think I might like the AstroImageJ one better. The background is a little bit brighter, so probably because the background got accentuated more. You can see that histogram line is right there. The background is darker in this one, but the galaxy doesn't have as rich of colors. So maybe actually doing the processing in AstroImageJ is actually better than doing the processing in GIMP like this. Now in GIMP, you can also play with the colors. can change the color levels. So for instance, if I go to value red, I can like increase the red color by going like that. Oh, sorry, that's decreasing the red color because I'm cutting out a bunch of it. So I guess increasing it would be the other way. That's why I was making it bluer. Yeah, see, this is making it redder. So you can play with this a little bit. The problem with playing with the colors directly is it does change the background. So maybe I could do the same thing with the green. That makes it too green in the background. So maybe there. Maybe cut some of the blue. So this is actually working a little bit better, and then go to the blue channel and you can do the same thing. I'll stop messing around and just finish up this video, but just want to demonstrate some of the things that you can do here to sort of get the best image. And now we're just playing like, what do we think by eye? So actually, I think this one is pretty good. I'm going to click OK. Now we've got a dark background. The galaxy is a little bit less saturated and maybe a little bit less structure, but I do like the darker background. Anyway, I'll stop. So this is basically how you create nice, pretty pictures using AstroImageJ and GIMP. Now, of course, I'm not an expert at this. Like I said, I am an expert in measurement of these bright objects, such as stars, but this at least gets you an introduction to making pretty pictures, and hopefully you can like start playing with this a little bit and make some pretty pictures on your own. Okay, great. Hope this has been helpful. I'll see you next time in one of these videos. Take care. Happy observing and clear skies. Bye.